Hello. Just a quick presentation of a new project I've been working on. I started a few weeks ago. I received a request about having some statistical information about a GIT repository. I searched around a little bit and I couldn't actually find any application that would give me the information I was being asked about. I found a nice tool which was GIT Stats. This one was very interesting. It came very close to what I needed. It generates a set of, in fact, I have that here. It generates a set of reports, static reports, makes a photo of your current state of your JIT repository, and it extracts a whole bunch of information from there. It looks very interesting. I mean, as you can see here, it gives me this is against the Evolutivo branch, the core boss evolution, next generation thing. As you can see here, we started the project in 2014, and you can see here how we kind of went over the commits during the years, and it gives us a lot of information, very nice, about the authors who's been working on that, the top committers and a whole bunch of stuff there, very interesting. It gives you the files and the lines and the tags. But what happened was that obviously what had to happen was as soon as I showed it to the person, they started saying, oh wow, how interesting, can I filter on this, and can I segment on that, and can I do a search for certain commits? And I sadly had to say no. This is static. It gives you what it gives you, and that's it. So I mean, I already knew that was going to happen, but I had to do that anyway. I wasn't going to go into that. So he asked me for a set of defined limits and ranges and things. So I added to the JIT stats. I added a pull request where I actually add some filtering options, which is always nice. We have another option in that project, and I managed to get what I was being asked for. But I just couldn't let it go because that ETL BI person in me knew that that had to be a better solution for that. Besides, I really like Metabase, so I thought that we should have a data warehouse to do this. So I created a open source project, which is GitStatDB. It's available on GitHub. Basically, it's the ETL process of a JIT repository. So you launch it against the JIT repository. It will show you, it will give you, for example, I have the output here of the call that I made for the Evolutivo project, the JIT repository. As you can see here, I implemented that in Python. This is the main thing. This is where the repository lives. This is the commercial name, which you'll see now. I'll show you. Description, and in this case I asked for Verbis so I could get and see what it was doing. It connects to the database because actually what we're doing here is an ETL process where we are reading all of the historical information, or most of the historical information of the JIT repository, and moving it into a database so that we can query and search and filter and do all of the amazing things that databases let us do. So it picks up the repository. It gives us a repository ID. The data warehouse I created actually supports more than one repository, although I wouldn't recommend that because it gets very big very fast. I did another repository which had 26,000 commits and a massive amount of branches, and then you have all of the information of the merges of all those branches, and the database gets big fast. So if you have more than one repository in there, it's going to get bigger, and besides, it complicates your queries because all of a sudden you have to start adding to all your queries this repository or that repository. So now, well, I mean, we had to have the database structure that way anyway, but really recommend that if you have more than one repository, you should save each one in one database. Anyway, it does manage that, and I know this is the incremental mode. This is the incremental mode. Okay, that's the incremental mode. Okay, so this is the other one. To show you both of them. Okay, this is the first one run. It read everything. It picked up 21,000 commits. It inserted them into the database. That took about 7 minutes. It found 376 branches, and that took about 3 minutes. Then it collected the tags, and it did the merge information and calculated a bunch of statistics, and that took about 12 minutes to do. Then once you have that, which is the first batch of information that you have to get in there, the procedure would be that you execute this every day or every few hours, depending on how I don't think you need that kind of granularity, but okay. The thing is that now, once you have this first batch where it reads all of the history of all the information, you execute it again with certain regularity, and it goes into incremental mode, where it sees that effectively that it has all of the information up to a certain commit, and then it just continues from there. So obviously things are a lot faster. In this case, it didn't find any commits. It found the same set of branches. It marked some branches deleted. Okay, so basically, if a branch is deleted, you pick up that information in the data warehouse, and it did some other stuff here. Okay. No new comments, so skipping statistics recalculation. Okay, that makes sense actually. This is a Python script, so you have the instructions on how to set it up in the README. I have it set up here, and we're gonna call this because I pushed a comment to the repository. Let's make sure I pick that up because I'm not sure I did. Let's do a GIT pull here. This is the directory here. Okay, and it brought in a new commit, and so now we go back to where we were, and it's that DB, and here we can run this command, this one. Okay, basically it's it's the commands I was just showing you there, the Python, the main, the repository, and the commercial name. I don't need these because they're already in there, and we have the recalculate statistics. I'm going to get rid of that. Okay, so basically we do this. This is the process that you should be doing every day. It found one commit. It is in incremental mode, and it's going to collect. It found the branches. It collect the branches, inserting the branches. If we had deleted one or whatever, it would have picked it up, and now it's recalculating the statistics because it did actually find one commit. That way we keep the data warehouse up to date every day. Okay, while that's working, we're gonna go and see what this actually gives us. Okay, I set up, my goal was kind of to see if I could get the same information that we got here, more or less. So using Metabase, I set up a bunch of questions that I connected to the data warehouse for that repository, and I did that. So for example, we have here repository information. If I open this, I can open it here, it gives me the information of that repository. Okay, the core bus, that when we started, who started it, where it lives, and all of the other information that we could check there. I have a whole bunch of information here. Top 5 committers in the last 12 months. As you can see, it's very, very incredible, and obviously we can just kind of say, okay, no, I just want the last 2 months, which is something that we couldn't do with GIT Stat. This is the reason that we need a data warehouse actually. So I actually did here also, let me see where that is. I created, besides all of the questions where I was kind of checking and seeing if we had all the information that we need, and something curious now that we'll see it on the other thing. I entertained myself creating a bunch of queries and making sure we had all the information we need, and finding the limits, and all the and adding some indexes to make things go faster and the like, and enhancing the statistics also to make sure we don't have to go and calculate things that we could be pre-calculated, and denormalizing and all that stuff. I created this dashboard, kind of simulating the dashboard that we had in GIT Stats. Okay, so the first page is information about the repository itself. Again, we have the repository info. This is the question I just showed you. We have the active days of the project, active days percentage. This is actually the days that we made commits from these 3,000 days. Number of committers, people who have contributors basically on the GitHub page, and the number of active commits per day, per active days, I think it was. Anyway, information, general information. Then we have the activity, the yearly activity. Notice here that this graph is very similar to this graph. The only difference is that here they went back 20 years for some reason, maybe I don't know why, instead of calculating exactly the years that were, but as you look at that, I mean, the values are very similar. I mean, 2,602, 226, 27. Okay, I don't know exactly why that could be, but anyway, as you can see, the form is actually very similar. The weekly activity, the hour activity. I have a heat map here to see exactly what years we were more active at what times, and the like. I mean, I was, like I said, kind of just checking what kind of information we could get out of there, what days of the week were more active, more calm on the weekend, not much more calm, but a little bit more calm. Months, January, February, March seems to be an active month, curiously. Well, it was the month that the project was born, maybe it has something to do with that. Authors, so kind of checking and simulating the other table. Here we have information about how many commits we made. This is very curious here, and should be cleaned up with ETL if we really wanted to do sane statistics. I guess at some point I changed the name of the author, and I added that space there at some point in the history of the project, which made us probably when we changed the internal, I'm not sure. Anyway, the thing is that there are two committers with the same email but different names. So JIT and the ETL process is separating them. That should be that's one of the things that should be fixed. That kind of try to match those users based on the email or something, and kind of join those commits together. Anyway, it gives us the information of when that person did the first commit, his last commit, how many days he's been active, he's been present, he's been active, and it ranks them by that number of. Then we have kind of a similar thing by year. Very interesting, this one, because it has the next top 5 after that, which is very interesting. Okay, so here we have, for example, 2025, which has more information. 2026, we just started. Here we have that I was the first, but then we have the scale here of people going down, no? which is kind of nice, a nice query. Authors by month, and we have some nice graphs here which are very similar. This is the committer one that we just showed, and this is a security one where we are actually counting. This one I did because it was one of the questions I was asked for. Can we filter only the commits that are about security? And I mean, we couldn't do that with GIT Stats, so this can be easily done here, because the question just basically goes into the commits and checks and searches for the commit message, which obviously has to have it should be following a naming convention so that you can find them. But anyway, you can actually filter by any kind of search string on the commits themselves and get the information you need, which is the whole goal of the project. Then we have files, basically how many files are in the default branch. We could do this for other branches, but basically it calculates only for the default branch, which is kind of the important one, and it gives you a classification of extensions. Then we have lines. Lines does not work. because I didn't implement it. It's a complex thing to calculate because we have to actually ask JIT to run through all of the files and get the size that that file had at the moment that it was committed and how it evolves through the history of the whole repository. So we have to make a slowly changing domain table with all of the changes through the years and all that stuff to actually get uh, a valuable photo of the evolution of all of the files. So I found these two tools, which are Tokay and Clock. They do this very well. They calculate that information for you. So at the moment, this is something that we should extend also. But at the moment, I would recommend just doing that and getting a photo of your data right now. And tags is nice also, kind of just goes into the JIT repository, gives you a list of the tags, and here you can see that these are links, so you can actually click on this and it takes you to the exact commit where that tag was made. And something curious was that, I don't know why, if we go to tags in JITstat, it didn't find the three of them, it just found one. Don't know why, I guess it could be an error, maybe I should report on that or check. But there are JIT3 tags in the project, and JITstat DB actually did do the ETL process correctly. So it's very easy. I mean, I don't know if you know. I mean, Metabase is incredibly easy to do anything. I mean, if you want to do a branch and we add a filter and we want to see the deleted branches, true, add filter and visualize, and boom. I mean, that easy. I get a list of all of the deleted branches, and we could get all of the commits that are on the deleted branches, and if they're merged or not. I mean, it's incredibly flexible and incredibly easy now to actually get information from your JIT repository. Anyway, I'm here to help if you need anything, because the reporting part is not open source. I kept that for myself because it's a little bit more work and it actually has passwords and things inside. So if you want this part, you want me to help you set it up, you want me to help you get the reports working or whatever, or set up Metabase for you, look for me and I'll help, very happily help. Thanks for watching.